We're going to now return to a ring that we know well, Z mod M, and we're going to try to characterize the units in Z mod M. So let's just look at a quick example. So how do we look for units? Well, let's look at Z mod 4 as a motivating example. What we can do is we can look at the multiplication table in Z mod 4. Why the multiplication table? Well, units are about producting and getting 1, or having multiplicative inverses rather. And so we want to look at the multiplication table for that. So let's just quickly fill this out. Let's see, 3 times 2 is 6. That's 2, that's a 2, that's a 0. All right, so if we look at this, we see that the elements with the multiplicative inverse are 1, of course. 1 times 1 is 1, great. And 3, 3 times 3 is 9. 9 is congruent to 1 mod 4, great. So from this table, we can learn here that the units in Z mod 4 are 1 and 4. Okay, now we want to try to figure out what's special with 1 and 3. Well, what's special with 1 and 3 here is that they're both relatively prime to 4. So GCD 1 and 4 is the same as the GCD of 3 and 4 is 1. And what this tells us is that we can use Bezout coefficients to do some stuff. And you did actually exactly this problem in one of the class group work exercises and on your homework. I just want to remind you that you did this problem in this video. So let's keep this to the side here and then go in and characterize the units. So we're going to fix some m bigger than 1. And we're going to look at the a's in Z such that the GCD of A and M is 1. That is, the guys that are relatively prime. Then what? Well, there exist x and y in Z. These are Bezout coefficients, such that ax plus my is 1. Now we're going to reduce mod m, that is, put bars over everything. So we're going to get a bar x bar plus m bar y bar is 1 bar. And that's going to tell us that a bar x bar is 1 bar. So A has a multiplicative inverse mod m, and it's x bar. So this tells us that A bar is in Z mod m cross. And now we want to show that only the guys that are relatively prime to Z mod m are in this set of units. Sometimes you'll hear it called a group of units, but we haven't got that terminology yet. Okay, so suppose you had some B bar in Z mod M cross. We want to show that B and M, any representative of the equivalence class of B, and M are relatively prime. Well, how can we do that? Well, since it's a unit, there exists some, I don't know, C bar in Z mod M cross such that B bar C bar is 1 bar, or equivalently, by multiplication, by the rule for multiplication, B times C bar is 1 bar. But this tells us that BC is congruent to 1 mod M, which then again tells us that, well, BC minus 1 is a multiple of M for some k and z. That's the definition of congruence. But this would tell us that by carefully reordering, we have to do a negative k if we move it over. BC plus M times negative k is 1. But this tells us that the GCD of B and M is 1. In particular, the GCD of two integers is the least value we can put to the right-hand side of this equality that has a solution to bx plus my is 1. And we found one solution where it's 1, and so that's the least value we can put on the right, therefore it is the GCD. Okay, so this tells us then that we have some information about the units in Z mod M, and it's kind of unsurprising. Well, they're just all the guys that are coprime to M. So another example, we can do a bunch of these now. Okay, let's see. What are our units here? Well, it should be 1 and 2, because everything in Z mod 3 is coprime. Let's go. We already did Z mod 4. Let's do Z mod 5. Well, it should be 1, 2, 3, 4, because every element is every non-zero element is coprime to 5, because 5 is prime. And then in 6, it's actually not a lot. It's just 1 and 5, because 2, 3, and 4 all have something in common with 6, and then you can keep filling this out. So we have some information about units here. And I'd like to take a minute in Z mod 6, and let's look at associates of elements. So look at associates in Z mod 6. Oops, we're not going to look at the units, we're going to look at the associates, with the unit, keeping in mind the units are 1 and 5. All right, so let's look at everything that 2 is associated to. Well, first of all, I guess we can start with 1. Let's start with 1. So 1 is associated to, let me do well, I'll write it out for the first line. Well, why are they associated? Because if I multiply 1 by the unit 5, we get 5. Great. 2 is associated to 2 and 2 times 5. So, oh shoot, let me put the 1 here as well. 2 and 2 times 5. What's 2 times 5 is 10, but mod 6 is 4. So it's associated to itself, of course, and 4. And then 3 is associated to, well, itself, and then whatever 5 times 3 is mod 6. I think 5 times 3 mod 6 is, again, just 3. So it's just, yeah, it's just associated to itself. And 4, well, 4 should be associated to 2 and itself again. In fact, 5 times 4 is 20, mod 6 is 2. And then lastly, 5 is just going to be associated to 1 and 5. Those are some examples of computing associates.